All right, starting on 43, we have our launch. It says each piece of paper shows a numerical expression or an algebraic expression. Numerical being the numbers, algebraic being the ones with the variables in them. Can you show the same total value using fewer pieces of paper? Write your expression and explain your reasoning. Well, this is just like combining like terms. So as you can see, I've circled the number and I put a box around the 2x. I'm going to put a triangle around the y. So around this one, since it's 3x, that should go a box. This is a number, so that should have a circle. And this one here is a negative 3y, so this one should have a triangle. Now I'm just combining my like terms. So 3x and 2x is going to give us 5x. Negative 5 and a positive 22 is going to give us a positive 17. And then we have our 4y and our negative 3y, which just gives us 1y, or y. So can we show the same total using fewer pieces of paper? Well, yes, once we combine these, we use fewer pieces of paper by having just 1, 2, 3 pieces. I want you to leave some space here. We're going to write key concepts in just a second, but first we're going to answer how this reflect question. How does equality help you solve this problem? Well, you know that equality just means basically these two pieces of paper equals this piece of paper. And this piece of paper and this piece of paper equals this piece of paper, and this piece of paper and that piece of paper equals this piece of paper. So you know that fewer pieces of paper could be represented, can represent multiple tiles. So we'll write 1 tile, or pieces of paper, can represent multiple tiles. So if we call these things up here tiles instead of pieces of paper. And again, this is just a launch to kind of get our brain going, but today we're actually talking about solving systems of linear equations using the addition method. So under your key concepts, I want you to write addition method, and I'm going to write some steps here. I'm just going to pause and write them out so you guys don't have to sit here and watch me write them out. Okay, so here are some steps to using addition method, and if you need to pause right now and write these in, that's great, but I'm going to talk about them. So the first thing you want to do is eliminate one variable, and I'm going to write big red X because you're literally eliminating it, you're getting rid of it. Then you're going to pick the variable basically that you didn't eliminate, and you're going to solve for that variable. Then once you get that, so you'll get like y equals 2. Then you're going to take this and you're going to substitute first variable in and solve for the second variable. Then you will write your solution. And remember, our solution to a system of equations is in the form of an ordered pair. So your answer should look like this. This will make more sense in just a moment. Okay, first got it. We are now on page 144. Is the addition method a good choice for solving the system of equations? And the answer is yes. Why? Because we have opposite signs right here. First off, our coefficients are the same for x. Remember that invisible one is right here. And they have opposite signs. This is a positive x, this is a negative x. So they are easily eliminated. We're using addition, so remember we set up our big addition problem. I'm going to change my color. And these x's get eliminated. So we just eliminated our first variable. Now we add these together, we get 3y equals 12. So now we solve for y. How do we solve for y? Divide both sides by 3, and we get y equals 4. So we've just solved for our first variable. Now what we do with this is we substitute this back into one of our original equations and we solve for x. So I would say we should do the second equation because it doesn't have a negative x. So I'm going to put x plus 2, and instead of y, I'm going to write 4 because y equals 4 equals 8. So we get x plus 8 equals 8 minus 8 from both sides, and we get x equals 0. So now that we've gotten our first variable and our second variable, we can write our solution in an ordered pair. So 0 goes here because remember x goes first, 4 goes there because y goes second. So again, 0, 4 is where these two lines will intersect if we were to graph them on a coordinate plane. Alright, next example. We're still on page 144. It says solve the systems of equations by addition. So we want to make sure, just like yesterday, our x's are lined up, our y's are lined up, there's an equal sign here, and there's a number here. We put our addition sign, and we're solving a big old equation. Now, first step we want to do is eliminate a variable. Well, we look for opposite signs. 5y here, negative 5y here. These two are easily eliminated. Now we just add up the rest. 2x plus 6x is 8x. 17 plus a negative 9 is going to give us 8. We divide both sides by 8. And we get x equals 1. Now, so we've eliminated a variable, we've solved for our first variable, now we're going to solve for our second variable, which is y. So we rewrite one of the equations, but instead of x, we're going to write 1. I'm going to pick the first equation because it's all positive. So 2, and instead of this x, I'm going to write 1, and I'm keeping it color-coded because 1 was blue down here, plus 5y equals 17. So now we solve for y because we have our x. So we get 2 plus 5y equals 17. We minus 2 from both sides. We get 5y equals 15. Now we want to get that y alone, so we divide both sides by 5, and y equals 3. Now that we have our first variable and our second variable, all we need to do is rewrite. We write our solution in an ordered pair. So remember, x goes first, y goes second, and of course they're in parentheses. So 1, 3 is where these two lines would intersect if we were to graph them. Okay, so now for our got it. Two buildings in an apartment complex, building A and building B, have a total of 120 apartments. The difference in the number of apartments between the two buildings is 16 apartments. How many apartments does each building have? First thing I want to do is define our variables. So we're going to let x equal number of apartments, and I'm going to abbreviate that, in building A. So then we're going to let y equal number of apartments in, what do you think, building B. So basically, x is the number of apartments in A, y is the number of apartments in B. We're going to try and figure out how many, remember, how many apartments does each building have? Okay, so let's set up our equation. There's going to be two equations because we're working with systems of equations, so we know there's going to be two. So building A and building B have a total of 120. So we know building A, which is x, plus building B, which is y, equals 120 apartments. Now it says the difference in the number of apartments between the two buildings is 16. So all this means is, remember, difference implies subtraction. This just means x minus y equals 16. So x plus y equals 120. x minus y equals 16. Now what they're wanting us to do here is use elimination method, use addition method. So let's go ahead and do that. Which one are we going to eliminate? Well, we're going to eliminate y, because they have opposite signs. So we get 2x equals 136. We divide both sides by 2. So x equals 68. So what does that mean? That means x is the number of apartments in building A. So building A has 68 apartments. Now let's solve for building B. So we know it's 68. And again, I'm going to keep it color coordinated. Plus y equals 120. I'm just putting in 68 right here in our original equation. Plus y equals 120. Minus 68 from both sides. And I get y equals, let's see here, we'll do it the long way. 52. So that means there's 52 apartment buildings in building B and 68 apartment buildings in building A. And how do we write that as an ordered pair? 6, 52. And of course, since this is one, we need to answer in a complete sentence. There are 8 and 52 apartments in B. Okay, so now we're going to do the close on page 145. It says, what kinds of systems are easy to solve using addition? And what we want to make sure you know is that it's easiest to solve using addition when your coefficients are opposites. Be thinking, what's a coefficient? Well, the number in front of your x or y or a or b is your coefficient. So your coefficients are opposites. So what would be the opposite of this here? Well, it would be something like negative 3x, because 3 and negative 3 are opposites. So this would be a good system to solve using addition if you saw something like this. All right, so go ahead and get started on your 6.5 homework. Remember, you need 70% accuracy or higher in order to get full credit, and you need to show your work on a separate piece of paper.